You see those massive steel tanks all over our industrial landscapes, right? Well, they're not just big cans. They are seriously complex structures, and the rules that keep them from failing are incredibly precise and, honestly, absolutely critical. So let's dive in and take a look at the blueprint for their safety.
I mean, think about it for a second. How do you actually repair one of those things? You can't just slap a patch on it and call it a day. We're talking about enormous forces, sometimes hazardous materials inside. The risk of a catastrophic failure is very, very real. So how do engineers make sure a repair is as strong as, or maybe even stronger than, the original design?
Well, to answer that, we've got a roadmap. First, we're going to talk about why the specific type of steel is so important. Then, we'll get into the official rulebook. We'll look at the standards for using brand new materials, then do some detective work on old tanks, and finally, we'll see how it all gets welded together.
Okay, so why all the fuss about materials? It's because these tanks are kind of like the invisible shields of our modern world. They hold everything from oil and gas to the water we drink. The steel itself is pretty much the first and last line of defense against a disaster.
And this quote it nails it perfectly. See, different steels have totally different properties. Their strength, how they handle cold, their resistance to corrosion. Using the wrong one isn't just going to make a bad tank. It creates a ticking time bomb. It's a dangerously unpredictable structure.
So, how do we make sure everybody is using the right ingredients for the cake? Well, that's where the official rulebook comes in. We turn to this document, API653, and specifically, we're going to look at Section 7.
API653, which comes from the American Petroleum Institute, is basically the Bible for tank maintenance. It's this super comprehensive guide that lays out all the engineering requirements to make sure these massive structures stay safe and reliable for their entire lives.
And here we are, looking at the actual text from the standard. We're zooming right in on Section 7 because that's the heart of what we're talking about today. This is the part that spells out exactly what materials you can, and more importantly, can't use when you're working on these tanks.
All right, let's see how this actually works. We'll start with the most straightforward case. You're using brand new materials to fix a tank. So here it is, the golden rule, right in Section 7.2. You see that word must? They put it in all caps for a reason. It is absolutely non-negotiable. If you're adding a new piece of steel, it has to meet today's standards. You can't just grab some old steel you have lying around from another project. No way.
And why so strict? Well, it's because using current, certified materials means you know exactly what you're working with. You know its strength, you know how it'll react to what's in the tank, you can predict how it will behave under pressure, and, this is a big one, you know it can be welded properly and safely.
But it's not always that simple, is it? What happens when you're dealing with a really old tank and the original blueprints are just gone? This is where it gets really interesting.
And this happens all the time. Decades ago, paperwork wasn't what it is today. So how in the world do you safely repair a structure when you don't even know what it's made of? You definitely can't guess.
Thankfully, the standard actually planned for this exact problem. If we go back to our document, Section 7.3.1.2 gives engineers a clear, almost forensic procedure. It's a step-by-step guide for identifying these mystery materials.
And here's that process. First, you become a historian. You hunt for any scrap of original paperwork you can find. If that's a dead end, you become a chemist. You physically take a sample of the steel and analyze its chemical makeup. And finally, you become a physicist, running mechanical tests, literally pulling and bending the steel to confirm its strength and toughness.
This whole process is so important because material science is always getting better. For instance, the standard points out an old type of steel, ASTM A7, was taken off the market decades ago. Why? It just wasn't as strong or consistent as what we have now. So the standard requires any replacement to meet a modern, superior spec, like ASTM A36, which is stronger and easier to weld. It's all about bringing old tanks up to modern safety standards.
Okay, so you figured out your old steel and you've got your new, modern steel plate ready to go. Now, you have to join them. And that brings us to the final and absolutely critical piece of the puzzle, the welding. Section 7.4 puts it very plainly. Now, welding consumables is just a fancy term for the welding rods or wire you use. And they have to match the American Welding Society, or AWS, classification for that exact job. So what does that actually mean?
It means this. A weld isn't just filler material. It is a structural part of the tank. The glue, so to speak, has to be chemically compatible with the steel it's joining.
and it needs to be just as strong, if not stronger. If you use the wrong welding rod, you're creating a weak point that could undermine the entire repair. This chart shows the idea perfectly. Look, the strength of the original plate, the strength of the new plate, and the strength of the weld itself, they all have to match up. There can be absolutely no weak link in this chain. The whole thing has to be engineered to work as one unified system. So, after all these details about old steel, new steel, welding, all of it, what's the one thing that truly matters? It all boils down to this one single goal: achieving and maintaining structural integrity. That's it.
And the reason this all matters is actually pretty simple and incredibly important. Following these rules protects the lives of the people who work near these tanks and live in the communities around them. It prevents absolutely devastating environmental spills. And it makes sure that the critical infrastructure we all depend on every single day is safe, sound, and reliable. The rules in API653 are the best practices we have today, built on decades of hard-won experience. But it does leave you with a question, right? As our materials science keeps pushing forward, what are the tanks of tomorrow going to be made of? New composites? Smart alloys? And what new rules will we have to write to keep them safe?